So I was asked to have a few words about the question of how new low-dose CT centers adapt the small lung nodule profile. And I shortened that a bit. How do we do it in real-world screening settings? So we have a project running in Europe that's focused on strengthening the screening of lung cancer. And I want to go from that perspective with 37 partners in 15 EU member states, with 13 active screening pilots running in 11 different countries. So it's a lot of diversity there. The first paper was published last year that gives an overview of what is actually the purpose of the project. But the point I wanted to bring up is that in Europe, we always use volumetry. So that's a very, very important topic for us. And everyone's also using volume doubling time as the point to move on into interventions. So this year there were 2 publications. There were also a lot of authors who are involved in the SOLACE project, and they mention how you can adapt the volume doubling time, what's the way to use it in practice, but it doesn't really touch on technical aspects. So technical aspects are also something that we want to look at. From my perspective as a physicist, that's the most interesting topic, of course. So we try to find out what actually are the CT image acquisition protocols that are used for lung cancer screening. So we had this opinion article published this year and wanted to advertise the survey that was supposed to be international. And I wanted to bring up just one question that we asked there, and that is what reconstruction algorithm type was used for the image reconstruction. These are the answer options that were available. So the old version is the filtered back projection. Then there's iterative reconstruction with statistical modeling, and it can also be used with the newest versions with deep learning support. So we'll quickly present the results we got from the answers, and you can see we still got all of these types in practice in lung cancer screening, but answers are probably mostly from research sites, so there's a bias to that. But there are still some people using filtered back projection, definitely. Most people use statistical modeling based iterative reconstruction, but some are already using deep learning supported iterative reconstruction, which means that some type of AI is already involved in that. So then the question is, what are the consequences of that if we look at volumetry and the volume doubling time? Well, if you think about the screening process, it might take decades for a single participant in the screening process. And it was mentioned before that, well, the device might change, the software might change, and with these different types of reconstruction algorithms, you have different images. Yes, you can reduce the noise, and yes, you reduce the radiation exposure, but that also comes at the cost that the image is different, and then the volume you will calculate is also different. So, and then if we want to add something, for example, emphysema, how would the question is, how would the impact be on those measurements with these changes in reconstruction algorithms? So that would be really interesting to know.